Okay, so welcome back. Our objectives are still to go through 3D volume rotations and 3D volume by cross sections. This is more of a review class. We'll be quizzing towards the beginning of next week. So I'm going to go through all of our sample problems for cross sections, disk method, shell method. And we'll finish off there for today. Okay, so starting off with our cross sections. Told that the base of this solid is enclosed by these two functions, so y equals 0 and y equals negative x squared over 4. And that cross sections perpendicular to the y-axis are semicircles. Okay, so I am perpendicular to the y-axis. So if I'm perpendicular to the y-axis, I have to form a 90-degree angle with that y-axis, which would look like this. And those cross sections are semicircles, so popping out of the page would look like this. So mini half circles. It's cross sections popping out of the page. So I've got this 2D area here in yellow and an infinitely small change in width. Okay, so in this case, our depth is a change in y. And then to get the area of this two-dimensional cross-section, I'll need to know what the radius is. Okay, so let's see who I've got. Okay, it looks like I've got over on Zoom Abby, Andrew, and Eric. So I'm going to start with Abby. Come out here so I can get my formulas again. What would the radius be for this semicircle?
Radius will be like first the thing is the radius is y1 minus y2 over 2.
So that would give us the distance between these two functions. That would give me a line going up and down. But we want our cross sections to be perpendicular to the y-axis. We're actually going the opposite direction.
No.
So I'm looking for this distance here in green.
It's just
Is it going to be based on an x value or a y value?
x.
X value, okay. So in this case, it's actually just x. Wherever we pick our x value here right now, whatever our x value is right now, will be the distance from that x value to 0. So our radius is x. And that's actually all we need. Our depth is dy. Okay, so I'm going to use that radius. We're going to build our area of this two-dimensional cross-section. Abby, what's the area of the semicircle?
1/2 pi r squared.
Okay, 1/2 times pi times r squared is perfect. So I'm going to plug in r is x, and we'll get pi over 2 x squared. Okay, I'm going to jump down to Andrew. Andrew, so I want to set up an integral that will allow me to keep adding infinitely many of these semicircles from the top of this function to the bottom of this function. What should I integrate?
I should integrate x squared dy.
Okay, x squared dy. I need to integrate my area times dy though, so I do have a constant out here.
Well, that's pi over 2.
Pi over 2, perfect. And then what's my starting y value and what's my ending y value then, since I'm integrating in terms of y?
I should integrate -2 to +2.
Those are x values.
Oh, so from 0 to 1, +1.
From 0 to +1, perfect. So whatever your depth is, that tells you what these a and b have to be in terms of. That does mean that I'm going to have to change this x squared to become in terms of y though, before I can integrate. So to do that, I'm going to use our equation. We know that y is equal to negative x squared over 4 plus 1. So if I solve for x squared, we should be able to substitute before we integrate. So I'm going to move this x squared over 4 over, so it's positive. And move the y over, which will make it negative. And then multiply by 4. X squared is equal to 4 minus 4y. And now I can substitute in for my integral. Okay, I'm going to jump over to Eric. Eric, how can we integrate this?
4x minus 4y squared over 2.
Okay, 4y minus 4y squared over 2 from 0 to 1. Okay, we're going to plug in upper bound and subtract lower bound. If I plug in my upper bound, this will be 1. If I plug in my lower bound, it'll be 0. I'll have to multiply the pi halves times both. When I plug in 0, I'll have 0 minus 0. If I plug in 1, I'll have 4 minus 4 halves. I guess I'll leave like that for now. So this is 4 minus 2 is 2 times pi halves is pi. Okay, any questions on what we did here? No. Okay, the formula for volume by cross sections. is that our volume is always equal to the integral from a to b of our area times our depth. So that's going to be dy if we're building cross sections perpendicular to the y-axis. Or if we're building cross sections perpendicular to the x-axis, that'll be our integral from a to b of our area times dx. All right, any questions here? Nope. Okay, so that's it for Zoom. So I'm gonna jump over to Skype, where I've got, looks like Nikita and Kyle. Okay, so this time we are building cross sections perpendicular to the x-axis as semicircles. With the base of our solid being y equals 4 and x squared over 9. So I'm going to write those equations over here really quick. So that I can zoom in. And then cross sections perpendicular to the x-axis are semicircles. So perpendicular to the x-axis this time, 90-degree angle with the x-axis. Should give me a semicircular shape. Should look something like this. So we've got an infinitely small change in x. And then a 2D area that is a semicircle popping out of the page. Okay, so the hardest part of this, starting with Nikita. What will our radius be?
I suppose 4 minus x squared.
Okay, 4 minus x squared over 9 would give me the whole distance between the two y values. So
4 minus x squared over 9 divided by 2.
divided by 2, perfect. So I'm going to write multiplied by 1/2, so that I don't have a fraction inside a fraction, but you're right. So if I cut that distance between the two y values in half, then you'll end up with the radius. Okay, so I'm going to distribute. This will give me, our radius is equal to 2 minus x squared over 18. Okay, then if I want to make that an area, jumping over to Kyle. Kyle, if I want this to be an area, what would the area of my semicircle be?
The area would be area is pi r squared, right? So it's going to be pi r, so 2 minus x squared over 18 squared.
Okay, we're really close. Area of a whole circle is pi r squared.
Oh, 1/2.
1/2 pi r squared. Okay. So that'll give me pi over 2 times 2 minus x squared over 18 squared. Okay. So I'm going to throw this up into an integral that will allow us to add all of these cross sections from our start point to end point, which this time wasn't given. So I do need to solve for the start point and end point first. So let's see, I've got next is Andrew.
Yes.
If I don't trust this graph to be drawn to scale, how would you find your start point and end point?
Um. I will make an equation 4 equals x squared over 9,
Perfect.
and also for x.
Okay, so that gives me 36 is equal to x squared, or x equals plus or minus 6 are my intersection points, which will tell us our start point and end point. Okay, so over to Abby. I need to put all of this into an equation. So that I can integrate and add all of these cross sections together to get my total volume. Zoom out a little bit. What should our equation be?
Mm, uh, b equals pi half times 2x.
Okay, times the
Oh, no,
integral.
no, no. Wait. Times the integral of. Is it -6 to 6?
From -6 to 6, okay.
And then. Or.
Oh, we don't have to square just yet, so if you want to throw it in, you
Oh.
can.
Do we just derive it to an integral?
Um,
Wait.
we've got our area down here in yellow.
Yes.
Okay, so you've got your pi halves, and we need to copy the rest of that.
Up 2x minus x squared over 18 to the power of 2 power square
Okay,
dx.
dx. Awesome. All right. So now we can go ahead and expand that, and then after we've expanded, we'll be able to integrate. So if I expand this, Eric, what's going to happen?
You have to integrate.
Okay, I do need to integrate, but before I can integrate, I'll need to expand this.
The square.
Right, so what is 2 minus x squared over 18 squared? We need
X to the fourth power over
I actually don't know 18 squared off the top of my head either, but we can leave this as 18 squared for now, I think.
324
Okay.
minus 2x squared over 9 and plus 4.
Okay, so that 2x squared over 9 was 2 times 2 times negative x squared over 18, and the 2 and the 18 canceled out. Dx. Okay, and now we're ready to integrate. So I'm going to kick this over to Nikita.
Oh, okay, so it's gonna be pi over 2 x to the 5th over just second over 1620
Okay.
minus 2 oh no actually yeah 2x cubed over 27 plus 4x.
Okay, from negative 6 to 6. Looks good. So we'll go in and plug in our upper bound and subtract our lower bound. So this will be 6 to the 5th power. Oh, I'm actually out of space is why. Alright, good on here then. Okay, so all of these, I'm subtracting the negative of what we had at the other side, since these are all odd powers. So that's just going to double this. So I could say our volume is 2 times pi halves times whatever this is. Okay, so we said 1620 was 18 squared. 18 is 6 by 3. And then we multiplied by 5. So if we had 18 squared, that's 6 squared by 3 squared by 5 was our 1620, which will allow us to cancel 2 of these 6's. Minus 2 by 6 cubed over 3 cubed plus 24. So 6 is 3 by 2. So this is going to leave me with my 3 cubed will cancel with the 3 cubed. I'll be left with 2 cubed on top. We got 6 to the 5th and 6 to the 2nd power can cancel. Will leave me with 6 cubed. Out of that 6 cubed, I can pull out the 3 squared if I want. That'll leave me with 2 squared times 6. And I think that's all I can cancel. Okay, so 2 squared is 4 times 6 is 24. So I've got 24 over 5. Minus 2 to the 4th power is 16 plus 24. Okay, the 24 minus 16 is 8. If I want to put that over 5 to get a common denominator, then that would give me 24 fifths minus 40 fifths, or 16 fifths times pi. Oops, wait, I'm not subtracting. I am adding. Which makes more sense. We shouldn't have a negative volume. So that is 64 pi fifths. Okay, I'm gonna check my answer really quick, make sure I'm okay. Sixty-four pi fifths. Yeah, we're fine. Okay. Any questions on what we did? Okay, so that's all volume by cross sections. I'm gonna do one disk method problem and then one shell method problem, and we'll stop there. Let's do one where we're rotating above, because those are a little bit harder, I think. Okay, so we were told our area is bounded by y equals -1, y equals -x squared, and y equals 2 for our axis. So with all that, I'm rotating about a horizontal line. So next is Kyle. Kyle, if I'm rotating about a horizontal line, will I need to use disk method or shell method?
Shell method.
So if we're rotating around a horizontal line, we'll need to use disk method actually. We use shell method whenever our axis is vertical, in order to create our cylindrical shells. If our axis is horizontal instead, like this one, then we'll need to create two-dimensional disks and stack them on top of each other like this. So if this one is disk method, I'm going to stick to you for a minute. Then I'll need two things for this method. I need an R1, which is my long radius, my distance from the axis to the outside function. And I need an R2, is a short radius, is the distance from the axis to the innermost function. If I draw that, that'll look like this. Axis to the inside function. And axis to the outside function. Okay, what is my R1?
-1.
-1 would get me to 0, so that's this much.
So it's -x squared.
And -x squared is this distance. Gets me to the top function from 0. I want to go from the black line to this bottom blue line. What's the formula for the black line?
Oh, so just 2.
Okay, so that's 2 will
So
get me...
R1 is 2 minus -1.
Perfect. Which will end up being 3. Which makes sense. This is a constant radius. It doesn't matter what our x value is. This line all the way through is always 3. Okay, our red line does change though. Our red line goes from the black line to the topmost blue function. So what should that be?
2 minus -x squared.
Okay, which is the same thing as 2 plus x squared. Okay, so I'm going to use those to create disks that will end up looking like this. Oop, not drawn red. Okay, I'll have an inside disk that we cut out from a larger outside disk. And then each of those disks will have an infinitely small width, a depth to it. Okay, so here in green is our large disk. With our radius still showing in the dark green. And then here in red, or peach rather, so I can keep our radius showing, is the small hole we're going to cut out of it by subtracting this smaller area from the larger one. Okay, then we've got an infinitely small depth. Which will look like this. Okay, that depth is our change in x. Okay, so now I need our general formula for this method. Oh, that's as far as I can go. My general formula for this method is this. pi times the integral of r1 squared minus r2 squared in terms of x from a to b. So for us, to take these areas and use them to create areas that are circles. Each circle will have an area of pi times r squared. And then in order to make them a depth, I'll have to multiply by dx. Okay, they did not give us start point and end point, A and B. So I'm going to jump over to Andrew. Actually, Andrew, you answered this one last time, I think. So I'm going to jump to Abby. Abby, how can I find my start point and end point if they didn't give it to us?
Looking at the where it touches so it's -1 and 1.
Okay, where it touches, what you write is -1 and 1. If you can't see it from the graph, then you can solve for those intersects by setting your y values equal to each other. -1 equals -x squared, therefore x squared equals 1, or x equals plus or minus 1 is our intersects.
Oh.
Okay, so -1 and +1. So now I just need to simplify and integrate. Abby, sticking with you, what's going to happen if I square this? Zoom just crashed. Okay. All right, Zoom, can you hear me?
Yes.
Cool. Skype, can you hear me?
Yes.
Cool. They've got the apartment next to me is doing some work, and I think they kicked the internet. All right, so we're on Abby. What happens if I square this?
X. Oh, wait. Sorry, my connection dropped. It's x4 plus 4x squared plus 4.
Okay, that's perfect. And I'm going to subtract that from 9. So that leaves us with pi.
Combine like terms.
Right. So I've got 9 minus 4 is 5, minus x to the 4th minus 4x squared. I'm going to go ahead and move the 5 over to the other side. Times dx. Okay, next is Andrew. What happens when I integrate? Andrew, are you there?
Oh yes, sorry, the Wi-Fi.
That's
The
okay.
Wi-Fi was bad.
What happens when I integrate this?
It will be negative x to the fifth power over 5 minus 4x cubed over 3 plus 5x.
Okay, and we're integrating from -1 to 1. That does make this symmetric. So you can shortcut by doubling this if you want. I don't think I'm going to shortcut today, but if you did, you could plug in 1 and just double your answer. And the reason why that works is because 1 and -1 are symmetric about x equals 0. So this will be pi times all of our upper bound, -1/5 minus 4/3 plus 5 minus our lower bound, which will be positive 1/5 plus 4/3 minus 5. Okay, when we go to subtract, this will end up doubling all of those values. So I'll end up with pi times -2/5 minus 8/3 plus 10. So we'll get our common denominator. So that we can add straight across. So I've got -46 plus 150 is 104 over 15 times the pi I had on the outside. Gives us 104 pi over 15 for our volume. Okay, zoom all the way out. Any questions on anything we did here? Okay, then last one for today. I'm going to pick a shell method one. I think I'm going to do this one. So that looks like it's the hardest. So we've got our two equations. Oh, there we go. X squared plus 1 and root x plus 1. And our axis is at x equals 1. Okay, so starting with Eric. Eric, will this be dis method or shell method first?
Shell.
Okay, this is shell method. How do you know that this is shell method?
E. Thing on top.
Thing on top. Okay, so
The
Our axis is vertical, which tells us this is shell method. So you write the thing on top, but if your axis was a horizontal line instead, then we would need to use this method. Otherwise, we'd have to change our variables to be in terms of y instead of in terms of x. So for shell method, our general form is our volume is equal to 2 pi times the integral of RHW from a to b. So that means I need a radius, a height, and a width. So I'm going to drop a line. So that gives us a height that also gives us an infinitely small depth. And if I spin that around the axis to create our shell, I have to make this smaller. Oh, it's as small as I can go. Just exaggerate a little bit. Then we'll create our shell. So that shell has an infinitely small change in x, as well as the height that we just spun around. Okay, I was trying to leave a little bit of space so we could still see the functions, but I guess I'll get rid of it. Okay, so something like that. And then our radius will be our distance to the axis of rotation, which is here. If I wasn't exaggerating, then this would look like a circle instead of an oval. And this would be symmetric. Okay, so back to Eric. What is our height?
dx.
Oh, dx is our depth.
Oh.
So our height is going up and down like this. So that's being shown in red right now.
One.
Not one. This is going to be it's going to be variable based because our height will change from the start to the end. So if I blow this up, I'm looking for this distance. Now, open this up to anyone. What should our height be?
Square root of
y1
x plus
minus
1 minus x
2.
squared plus 1.
Okay, you're both right. So it's going to be the difference in my y values, which is what Andrew said, and then that difference in my y values is x squared plus 1 minus root x plus 1. So this is our top y minus bottom y, which is x squared plus 1 minus root x plus 1. Or I could say x squared minus square root x, since our 1's will cancel. Okay, and the last thing we need, move this over. The last thing we need is our radius, which is my distance from where we are right now to the axis of rotation. So this is the hardest part. Just write this in green to color code too. So I've got next is Nikita. If I zoom in here, we're looking for this green distance from where we are right now with our cross sections moving from A to B to the axis of rotation at x equals 1. So if this distance from 0 to the cross section is x, and this distance from 0 to the axis is 1, then what is the radial distance?
Minus x.
1 minus x, perfect. Okay, so that gives us everything we need. And from that point, we can just plug into the volume formula, which would give us this. Our volume is equal to 2 pi times the integral from our start point at 0 to our end point at 1 of our radius, 1 minus x, times our height, x squared minus root x, times our width, which is dx. Kyle, what happens when I multiply this out?
X cubed. Oh well, is square root.
Okay, so I've got x squared by 1 is x squared. X squared by your negative x is your negative x cubed you just gave me. This square root of x is the same thing as x to the 1/2 power, if that helps.
X squared.
Okay, so x cubed and minus, could it be minus square root of x? Minus x square root of x.
So it'll be a
If
plus, I've got a
that's
negative negative. That'll be plus x root x. Okay, that's okay. And I guess I'll take another step and I'll rewrite these for power rule. So our volume will become 2 pi times the integral from 0 to 1 of negative x cubed. I'm just going to reorder these really quick. Plus x squared. Okay, my next one would be this one. And this is x to the 1/2 times x to the 1 will give me what?
x to 1/2 times x to the power of 1/2
This is
or
uh,
3 over
3 over 2. So that's x to the 1/2 times
3
x to the 1 will allow me to add my exponents. So that's 1/2 plus 2 halves is 3 halves. Okay, minus, I got my last term over here.
Minus x power 1/2.
X to the power of 1/2, okay. So I did two things really in that step. I probably should have done that as two separate lines, but I reordered these from greatest power to smallest power. And we converted these into a power row format. So into exponents. Okay, so I'm going to jump over to Andrew for integration.
Oh. Negative x to the fourth power over 4 plus 3 to the third power over 3 plus 3 over wait 2 over 6
This is x to the 3/2, so it'll be
2 over 5
okay, 2 over 5. 2 over 5. X to
x to 5 over 2 power
perfect.
minus 2 over 3x 3 over 2 power.
Okay, awesome. No, that's really hard with the language differences, but you did great. Okay, so I'll do upper bound minus lower bound. My lower bound is all zeros. So I'm going to write this out as just minus 0, but when I go to plug in 1, I've got negative 1/4 plus 1/3 plus 2/5 minus 2/3. What can my common denominator be? Who's next? I've got Abby next.
Yes.
I want to combine these, so what should the bottom of my fraction be so that we can combine all of these?
Mm. No, wait. $60? I don't.
60, that works.
Oh, really?
So if you're not and you can always just multiply all of your numbers that are different together. And that will work for a common denominator. You may need to simplify if there's a smaller number that would work for all of these, but 60 will work for us. So I've got 4 times 15 is 60. 3 by 20 is 60. 5 by 11 is 60, times the 2 is 22. Oops, sorry, 5 by 12. And 2 by 20 is 40. Okay, so now I just need to add straight across and then multiply by the 2 pi, and then we're done. So Abby, can you finish this off?
Okay. Mm. Negative 11 over 60 times 2 pi.
Okay, our 2 and the 60 can cancel. So what's our final answer?
Negative 11 over 30 pi.
Pi, perfect. I feel like we shouldn't get a negative answer, but let me check. 11 over 30 pi. Okay, so that's just because I changed my order. That's fine. Okay, any questions on this one?
No.
All right.
Can this be sent in the group chat?
Yeah, I can send this in the group chat. Let me explain why that was negative really quick, because I didn't realize this until all the way to the end. But when we went to get our height, this should normally be top function minus bottom function. We actually did the opposite. We did bottom function minus top function. If you do that, the only thing that will change, you'll get the right answer, but you'll get the wrong sign. So if you end up with a negative area, you can always go back and check if your heights are reversed. Then just keep your answer and take the absolute value, and you'll be okay. I'll write a note on this, but
Like, can we see why is it the top? How do you determine the top and the bottom? Is the top is.
So our top should be right now this curve here. That is not a parabola. So that's going to be my rational function, root x plus 1. This bottom function is my parabola, so that's going to be my x squared function. If you're still not sure, go ahead and plug in a point. So if I plug in, we'll say 0.5, 1/2. Then I'll get, you should get a larger decimal for this one than you will get for this one. So you'll get 5/4 for your lower one. You should get more than 5/4 for your upper one. Okay, so I'm gonna make a note, but you guys are free to go. We do not have school Friday because of Labor Day. So you guys have a 3-day weekend.
Is shell method due tomorrow at midnight?
Yes. Heights are
Alright, see you.
catch you later. Top minus bottom.
Bye-bye.
Goodbye. So we did bottom minus top. Our answer will have the correct magnitude. But be negative.
Okay. I think I did that same thing on the homework for number 1.
Yeah, that's the most common mistake I make too.
Thank you.
Problem. Catch you later.
Bye.